So far, we've been able to build a lot of the basic gates in the basic logic gates in Logisim using NAND gates, and building more complicated gates using the simple gates. And what we want to do now is move on to building what are called multi-bit gates. And these gates are the same as their sort of fundamental counterparts, only instead of accepting single bits, single ones and zeros as their inputs, they accept multi-bit inputs, which we term as a bus. And so a bus is basically just, you can sort of think of it as a bunch of inputs kind of bundled together in such a way that it can represent multiple bits at a time. And so we're going to start off by just doing an example. We're going to do a 16-bit NOT gate. And so to begin with that, we're going to use our input here. We're going to make an input pin. But I want you to notice, so this input pin is a single bit input. If we can change it from a 1 to a 0 using the poke tool there. But if we look at that, over here on the selection portion, it tells you how many bits this is. It's a single bit input. We can modify that by clicking and then choosing, in this case, 16. And so now this is a 16-bit input, and we can change the individual values by poking those individual ones and zeros in whatever way we want to. And so we've got 8 bits on the top and 8 bits on the bottom for a total of 16 bits. I'll put all those back to 0. And now this represents a 16-bit input instead of a single bit input, and we can use that as an input to a gate. So what we want to do is make a NOT gate, like I said, a 16-bit NOT gate that will have the effect of negating every single one of these bits in the output. So we'll also have a 16-bit output that should be the negation of each of the individual inputs. So how do we do that? And this is kind of the model we'll follow for all of the multi-bit versions of our gates. So we're going to draw a wire, and this wire carries all 16 bits. It's called a bus. What we want to do is break that bus into the individual bits so that we can operate on them individually. And so in order to do that, we need a splitter. So we take a splitter, and I've already set, you'll need to change this, I've already set the fan out to 16 bits. Fan out just means how many outputs is this going to split to, and the input width also to 16. So you'll want to change that. I think the default is 2. So make them both 16 and attach the splitter there. Okay, and you can see if you change this, it modifies how big that splitter is. We want to make sure that the input matches the output. So I've got 16 individual outputs now representing each of the individual bits on the input. Again, the purpose here is to create a NOT gate, a 16-bit NOT gate. So now that I've split this into basically 16 individual outputs, I just want to negate each one. And since we already have built NOT gates, we can just use the existing NOT gate in Logisim to do that. And so this is a pretty simple thing to do. We're just going to NOT each of our inputs here. And I'm just going to do that. And we can see, this one's turned on because the original bit's turned off. And if I poke that first bit, first bit, I can see that it changes the input and output of that single bit. So I'm going to go ahead and create the rest of the individual NOT gates. I'm going to stagger them so that it's easy to see. And you can see this is pretty simple to do, but keep it nice and organized so that it's easy for you. And then eventually we'll recombine all of these individual bits back into a bus. And actually, if you want to speed things up, you can, I believe, copy and paste all of that. Paste it. I was hoping I could maybe move it. Yes. And I'll be able to reconnect. Oh, that's trouble. This is difficult. We'll copy and paste the rest of those, the second one down. But you can save yourself some time by copy and pasting here. I will copy and paste once again from here. And there we go. I've got NOT gates for all of my individual bits. I want to now recombine, and so I'm going to use a splitter again, but this time, if I put the splitter here, it doesn't do what I want. I need it to face the opposite direction, and so you can see facing, it says facing east. We want to make that face west, and we can see, oh, look at that, it turns around. Connect it up, okay, and then we can put a wire to the output, create an output pin. I've already created my output pin to be 16 data bits. You want to change that to 16, and then connect that up. And you can see when these are all zeros, these are all ones, so each of the individual bits has been negated. If I change individual bits in here, we can see that the negation happens in the output just the way I wanted. And that's a 16-bit NOT gate, which is useful when we have 16-bit inputs. Typically a computer nowadays has like it's a 64-bit machine, so every signal is basically 64 bits, and so we need gates that can handle that width of a bus. Now in our ALU, we're going to be using 16-bit inputs, so we won't get any bigger than this, but we'll want to implement 16-bit versions of several of the gates we've already made, like ands and ors. So hopefully that makes sense, and that helps you out in the other gates.